A dictionary is an unordered collection of elements which have a key and a value. The elements are called key-value pairs. The key, rather than an integer, is used to identify a value within the collection. The keys must be of immutable types. The values can be of any type, mutable or immutable. They can even be another dictionary, giving us nested dictionaries. Values can be repeated within a dictionary, but keys must be unique. We can create a dictionary by using a set of curly braces. For example, words equals open curly brace, close curly brace. We can populate a dictionary by explicitly typing in the keys and associated values. For example, animals equals open curly brace bear, panda, cat, leopard, dog, wolf, close curly brace. We can then extract a specific value using the associated key. For example, animals, open square bracket, bear, close square bracket. To add elements to an existing dictionary, we can simply add the key and assign a value to it. For example, animals, open square bracket, parrot, close square bracket, equals African gray. To delete an element, we can use the del operation. For example, del animals bear. Or we could delete an entire dictionary. For example, del animals. Notice that when we do that, animals is no longer listed in our variable explorer. If we try to use animals in any other statement, we will get an error message. We also have the ability to remove all of the elements of a dictionary. Before we can do that, let's first repopulate our animals dictionary. Now we can clear out the elements by typing animals.clear. Notice that animals still exists in the variable explorer, but the list of items is gone. It's simply an empty dictionary. The length of a dictionary is the number of key-value pairs or just the number of days. So again, let's repopulate our animals dictionary. And now we can find the length of it by typing len of animals. To get a list of keys, we can use the keys method. For example, key list equals animal.keys. Note, in Python 3, the results of keys are just iterables. You must explicitly convert them if you want a list. For example, keys list equals list animals.keys. The in operator tests whether a key is present in a dictionary. For example, dog in animals. If you attempt to access a key not in the dictionary, a key error exception is thrown. For example, animals undulate. If you need to access a key but do not know if it's in the dictionary, use dictionary.getKey. This returns none if the key is not found. It can also accept an optional argument to return a number if the key is absent. For example, dictionary.getKey, 0. So we can type result equals animals.getUndulate. And our result is none. You can also use in and not in to check if a key is included in a dictionary. For example, if this key in D or if this key not in D. So we can type if undulate in animals, print the strangest animal found is animals undulate, else print no strange animal was found. Now we come to the exercise. You may want to pause the video while you type in the following lines of code. We can iterate over the list of keys, for example, for k in d.keys, or simply for k in d. Iterating over values is more difficult since dictionaries are inherently unordered. We must convert it to an iterable. In Python 2.7 we can use iteratim. For example, for k, v in d.iteratim, print k, v. In both Python 2.7 and 3, we could also use item. For example, for k, v in d.items, print k, v. Although this may be slow for 2.7. The dictionary is a very powerful data structure, but its applications in scientific and engineering codes may not be immediately obvious, especially to a beginner. Lists and arrays often feel more natural to students since they seem to be more mathy. But there are at least two situations where dictionaries are a good choice of data structure. The first is when we need to find values by specific keys quickly. If you know the key, there is no need to loop through the entire dictionary. For example, it would be wrong to say for K in capitals, if capital K equals Arizona, print capital K. A better approach would be to say print capitals Arizona. In general, whenever it is more natural to retrieve a value from a non-integer reference, a dictionary is the appropriate data structure. For example, suppose you have a DNA sequence and you wish to count the number of occurrences of each nucleotide. You could set up a list. Nucleotides equals T, A, G, C. You would need a corresponding list. In count equals 0, 0, 0, 0. Then when writing your code, you would have to keep track of the count by index. For nucleotide in sequence, for I in range 3, if nucleotide equals nucleotides I, in count I plus equals 1. We'd then have to remember the correct order of the nucleotides list to do the further processing. Using a dictionary, we would simply write nucleotides equals T:0, A:0, G:0, C:0. For nucleotide in sequence, if nucleotide in nucleotides, nucleotides, nucleotide plus equals 1, else print illegal nucleotide symbol encountered. The second version is simpler, easier to manage, and likely faster.